Het moet hier ergens zijn. Laten we beginnen.
Als ik het zo bekijk, moet die planning wel goed komen.
Hier is het. Maar waar zoeken we eigenlijk naar? Dit onderdeel zou hier ergens moeten liggen.
person you just saw in the video is Daan van der Heijden. On the 7th of October 2017, his life changed in a single moment. During an off-road trip with his motorcycle, he broke his back. Since then, he has a spinal cord injury, which means he has no feeling and no control in his lower body and is wheelchair-bound. But when you get to know Daan, you will quickly notice that sitting still does not suit him at all. And yes, that's a bit ironic. Before his accident, Daan had a very active lifestyle. And in many ways, he still does. He plays wheelchair basketball at high level and does handbiking in his free time. He also got an almost 2-year-old daughter, and that is his biggest motivation. What makes Daan special is not what happened to him, but the way he deals with it. He focuses on what he can do and looks at opportunities, how impossible things can be possible again with some adjustments. And that is exactly why he is here today as our pilot of Project March 11. Project March is a student team from the Technical University of Delft that develops an exoskeleton for people with spinal cord injuries. With this exoskeleton, we want to help people stand and walk again. My name is Linde, and I'm the team manager of Project March 11. Tonight, we will show you what we have accomplished this past year. As a team, we can develop a lot of technology, but we cannot do this without someone who truly knows what it's like to live with a spinal cord injury. That is where Daan steps in. He helps us with everything, from safety and comfort to reminding us that sometimes simple solutions help best. And even though he cannot feel or move his legs, he can tell us how the exoskeleton feels. Daan has put a lot of time and energy in his project, and all of that completely voluntarily. When Daan walks in the exoskeleton, People mainly often see the technology, but for him, it means much more than that. Physically standing upright can have several benefits for physical and mental health. Sitting for long periods reduces the load on the bones, which can make them weaker over time. Standing upright would place stress on the bones again, which make them stronger. In addition, standing can support blood circulation and have a positive effect on cardiovascular health. Movement can also positively influence bladder and bowel function. But perhaps even more important is the mental impact of walking again. Think about something very common, like a spontaneous visit to a museum. For most of us, that sounds like an easy spontaneous activity, right? You walk inside, move to the room, and stop when something catches your attention. That experience is way different for Dan. The entire route has to be planned. Access depends on elevators, accessible routes, and the layout of the building. Artworks look different from another height. Standing and walking in an exoskeleton will change that experience significantly. This is about more than movement. It is about freedom and the opportunity to participate in everyday life that most of us take for granted. And that is exactly what our mission is about. Project March aims to improve the quality of life of people with spinal cord injuries by pushing the boundaries of exoskeleton technology. And at the same time, we aim to raise awareness for the daily limitations people with spinal cord injuries face. We want to inspire people.
A year ago, 26 students came together. Not because we knew each other, not because we knew what to expect, and certainly not because we knew how to build an exoskeleton. We come from 11 different academic backgrounds, spread across 5 departments. Half of us male, half female. A group with different perspectives, different interests, and different areas of expertise. So, on paper, we are a very diverse team. But from the beginning, we shared something very important. A strong motivation to make a real difference. Not just for ourselves, but first and foremost for our pilot, Dan. My name is Imelda, and I'm the project manager of Project March 11. To understand what we've been working towards this year, we need to look at the reality our pilot faces. Because, as you just heard, for someone with a spinal cord injury, visiting a museum is not straightforward. It requires planning. Is there an elevator? And can all visitors experience the exhibits equally? These are small questions, but they have a big impact. So the question becomes, how can we change this? We started the year with a very extensive research phase into existing exoskeleton technology and user experience. Because the goal was not only to build something that works, but something that truly adds value for the user. And that's why we, as Project March 11, wanted to build an exoskeleton that enables the pilot to visit a museum by walking self-balanced with hands-free control, allowing natural interactions with both the exhibits and loved ones, while requiring minimal assistance to put on and take off the exoskeleton by the end of July 2026. To make this team goal more tangible, we translated it into 3 clear pillars: walking self-balanced, hands-free control, and minimal assistance to put on and take off the exoskeleton. Tonight, we will show you in a live demonstration whether we have achieved the team goal for this year. But before that, I want to take you through what the year at Project March has looked like for each department, including the milestones we have achieved along the way. The mechanical department was responsible for designing and producing the entire exoskeleton. They began with initial sketches, which were then developed into 3D models and technical drawings. These drawings were then used to manufacture all parts of the system. But to produce these components, the team needed to follow hands-on workshops in the Dream Hall, learning techniques such as lading, milling, and CNC machining. The biggest milestone for this department was the full assembly of the exoskeleton in April, because this was the moment when all individual components came together and their work truly came to life for the first time. The electrical department was responsible for the entire electrical system of the exoskeleton. This includes custom-printed circuit boards and all wiring. This department was introduced to a particularly challenging task at the start of the year: implementing a new chip onto the motor controller. This did not only require hardware design adjustments, but also a complete rewrite of the embedded software architecture from the ground up. Therefore, I'm proud to say that this department has made significant progress in the development of this new chip, marking a major milestone for the entire system. Although it is not implemented in this year's exoskeleton, the work completed has laid a strong foundation for future integration. The team goal of self-balanced walking places significant responsibility on our software department. They embraced this challenge, and over the course of the year, they learned several new programming languages. They developed the necessary control systems and algorithms from the ground up. Their biggest milestone was seeing the first self-balanced steps in simulation. But from there, the next major challenge became clear: translating that success from simulation into real-life movement. The operations department starts the year with a very busy period. From day one, they start with finding partners and setting up collaborations, while also organizing all of our events and managing Project March's communication channels. A key milestone came in March, when the operations department organized one of the biggest events of our year: our design presentation. This was the first time where we could show our new design to the outside world in front of an audience of more than 500 people. And in all of this, the management department has played a crucial role. We supported the team by providing guidance and setting the right priorities in terms of time, budget, and technical expertise. But a year at Project March involves far more than you might expect at the start. It is not only about developing technical expertise, because at the same time, we developed just as many soft skills. We recruited an entirely new team. We learned how to communicate with press and media, and we represented our project at various exhibitions and events. As I mentioned earlier, we started the year as a team of 26 students who didn't know each other. But tonight, I'm proud to say that we are ending this year not just as a team, but as a close group of friends. One that works well together during long days on the project, but also one that has shared memorable moments outside of it. From team weekends to more in-depth sessions about mental well-being. And that combination of professional growth and personal connection has been essential to our journey. And with that, I would like to further introduce you to the team of Project March 11.
Mijn eerste indruk van het team was echt een super sociale groep.
Ze stellen zich gekkies eigenlijk.
Een hele hoop super gemotiveerde, echt super slimme mensen.
Super gezellig.
Mijn eerste indruk van het team: extreem enthousiaste mensen.
Ik voelde me eigenlijk gelijk heel erg vertrouwd bij iedereen.
Heel divers.
Eigenlijk heel welkomend en open.
Ik denk dat we heel erg naar elkaar toe zijn gegroeid. Mijn highlight van het jaar was wel de design presentation. Dat was echt wel een heel mooi gezamenlijk moment van euforie.
Een keer dat Door Control ging werken.
Toen we de Live the Witch Shift getuned hadden.
Iedere dag starten en koffietjes drinken met mijn department. De eerste keer dat je zag dat de code die je echt zelf hebt geschreven werken op het exoskelet.
We hebben in totaal 48.256 uur met het hele team aan March besteed.
En we hebben met de acquisitiegroep ongeveer 392 bedrijven benaderd.
Ik denk dat ik wel richting de 2.500 mails heb gestuurd dit jaar.
75 linears in en uit elkaar heb gehaald.
Ik heb dit jaar 164 designs gemaakt.
Ik denk dat ik ongeveer 40 onderdelen heb gemaakt met de CNC.
Ik heb 13 bordjes gemaakt.
Wel de enkel.
Ik heb 389 documentjes getypt.
Dit jaar denk ik ongeveer 124 GPC-modellen getraind.
Ik heb 74 renners gemaakt.
Wat ik meeneem uit dit jaar is een technische tekening die ik thuis mag ophangen.
Heel veel praktische kennis.
De ervaring die ik heb opgedaan met debuggen.
En een hoop vrienden voor het leven. Heel veel ervaring.
Ik hoop een slaapritme. The patience that comes with it.
Ik hoop gewoon een hele grote groep vrienden.
Ik denk dat ik veel meer heb geleerd van Project Mars dan dat ik ooit heb kunnen leren in mijn bachelor. Dus,
Mijn favoriete onderdeel, dat moet natuurlijk de partnerplate zijn.
Drives.
De computer natuurlijk.
De covers.
de linears. De ASRock. Footplate.
Ik wil de M-Drive.
Put device.
Onderbeenfixtures.
Het moment dat ik zou willen herbeleven is wel de filmdag in Rijksmuseum Boerhaven. Dat was heel gaaf.
Ik denk dat er wel bovenuit sprong dat we 3 dagen naar Duitsland zijn geweest. Dat was een hele grote beurs met 12 hallen.
De eerste stapjes van Daan.
Wat ik graag nog een keer zou willen meemaken is het watlopen op het teamweekend.
Dat we de onderdelen binnenkregen van onze producent en dat alles perfect in elkaar paste.
De eerste training waar we gelopen hebben met Daan.
Het teamweekend in België.
Sowieso alle vrijniveaus.
Ik ben nog steeds wel een beetje iemand met 2 linkerhanden. Maar ik ben dit jaar wel echt iets technischer geworden. Dat is wel nice.
Hoe wij met het hele software department het jaar door zijn gekomen en hoe grote stappen we hebben kunnen maken.
But working in a team of like 20 to 30 people that are like fully motivated and going for it has been honestly been fantastic.
Ik ben heel erg trots op hoe we als team hier staan. Dat we eigenlijk met elkaar één hecht team zijn en dat we met elkaar een heel gaaf project eigenlijk mogen doen.
Ja, ik denk dat ik heel erg trots ben op het feit dat het hele team zich hier gewoon elke dag keihard op heeft ingezet.
Let's dream big for a moment. The perfect exoskeleton. The perfect exoskeleton would be easy to use, putting it on in a couple minutes and standing up to enjoy an activity. During use, the inputs are easy to give, almost like it can read minds. The perfect exoskeleton would let the pilot walk without much effort. The pilot staying upright without the need to hold on to something. The perfect exoskeleton would react to its environment, the external forces of a high five or a hug being easily controlled. My name is Amy, and I'm a mechanical engineer of Project March 11.
Team goal, we looked at those dreams. And the realistic thing, the logical thing, would have been to admit that dreams like these take years to accomplish. Not just one. But we are Project March. And we were never really the realistic type. So we set our goals anyway. To walk self-balanced, to have hands-free control, and to get in and out of the exoskeleton with ease. And tonight we'll show you how we tackled these challenges. And more importantly, if we succeeded. But before we can show you how we tackled these challenges, we first need to understand how an exoskeleton works. My name is Mark, and I'm this year's lead software engineer.
And to understand how an exoskeleton works, we're going to start somewhere familiar. The human body. Your body starts with a skeleton. Without bones, you can't carry your own weight. Our exoskeleton is no different. The frame is the foundation. It carries the full load of both the pilot and the exoskeleton, so it has to be strong, stiff, and reliable. That is why we build it from solid aluminum and steel. All parts are designed entirely in-house by our own engineers. And we didn't just design it, we also manufactured 117 parts ourselves, taking on new skills like CNC machining and milling to get it exactly right. We also looked at the weight of the exoskeleton and tried to reduce this by putting force analysis on all parts. The result is a frame that is lighter, stronger, and built to our exact specifications. But bones give you structure, but they don't move on their own.
For movement, we need muscles. In our exoskeleton, movement comes from the joints. 10 motorized joints to be precise. 4 of these joints are rotational actuators, located in both the hips and the knees. These rotational actuators move, as expected, in a rotating manner, so the angle of the hips and knees can be controlled. The remaining 6 joints are powered by linear actuators. These linear actuators rotate a threaded axis to convert rotation to linear movement. These linear actuators were redesigned this year to boost durability and increase range of motion of the ankle. The linear actuators in the ankle work together in a coupled system, where they make both degrees of freedom of the ankle possible, by either working in the same or the opposite direction. A complete redesign of the ankle joint was needed to make space for this new joint. And together, these 10 joints make almost all movement of the human legs possible.
Besides active joints, we also use a passive joint for a motion that was still missing: opening and closing of the hips. This motion is particularly useful when putting on or taking off the exoskeleton. That is why this year we reintroduced a passive degree of freedom on the side of the hip frame, the hip hinge. This motion is non-motorized but can move by loosening a screw on the side of the hip frame. The hinge then allows for the legs to swing outwards. This creates enough space for the pilot to transfer into the exoskeleton with ease. But muscles don't contract on their own. For that, they need a signal. In your body, that's your nervous system, a network that carries instructions from your brain to every muscle and carries information from your senses back to the brain. Our exoskeleton is no different. Cables running through the entire system, connecting the brain to our 10 joints and to our 35 sensors. These sensors measure data like joint angle, forces on the joint, and battery percentage.
But the nervous system doesn't just carry signals. It also handles local communication, small, fast adjustments that never even reach the brain. And here, the human body analogy gets a little complicated. So, we'll borrow something else for just a moment. Think about cruise control in your car. You set the speed, and the car automatically adjusts to hills, headwinds, and road changes without you ever having to touch the pedal. And this is exactly how our motor controllers work. The computer decides where each joint needs to go, and the motor controller at that joint handles everything from there, reading the angle, the force on the joint, and the current flowing through the motor, and reacting within fractions of a millisecond to make sure the actual movement matches the plan.
Now we have structure and motion, but something still has to plan the movement. In your body, that's your brain. In an exoskeleton, that's the computer. The computer uses all 35 sensors to build a complete picture of where the exoskeleton is and what it's doing, and then decides what every single motor should do next, hundreds of times per second. The movement of the exoskeleton is guided by a predefined walking pattern. But what does a good walk actually look like? We define that through a carefully designed walking gait, tuning parameters like step length, step height, and timing. This is then optimized in simulation before refining it further, based on real-life testing with Dan. The result is a gait that is balanced, smooth, and comfortable for him specifically.
To determine the best action at any given moment, the computer could go through hundreds of possibilities in the simulation and pick the best one. And it can, but only around 40 times per second. And in a fast-moving system, that's too slow, because a lot can go wrong in that time. So we turn to machine learning. Instead of calculating from scratch every single time, we ran hundreds of thousands of simulations, found the correct response in each of them, and use that to train a neural network. So now, when the exoskeleton is walking, it doesn't calculate, it remembers. It reads the current situation and instantly knows what to do. The result? The exoskeleton redetermines its actions up to 200 times per second. That's a 5 times increase in speed. The method of machine learning we use is called Generative Predictive Control, or GPC for short. And what sets it apart is the way the model is trained. We start off with something called behavior cloning, where we literally try to copy the behavior we show it. But then we do something special. Because normal behavior cloning stops once the model is as good as its teacher. But we don't stop there. We let the model train itself. When the model thinks of something better than the teacher, we use that to train it. This way, the model can surpass the very behavior it learns from. So, we not only improve the speed of the response, but its quality too.
A robot that can walk on its own is impressive. It can calculate and predict the precise movements of its own components. But an exoskeleton isn't just a robot. It's an extension of a person, which means that none of this matters unless it works for Dan. That is why safety is a big priority. Both Dan and all electronic components need to be well protected during use. That is why covers are essential in offering both functionality and aesthetics. This year, padding was added to the covers to boost durability and user-friendliness. Our second big safety concern is that Dan needs to be fixed to the exoskeleton. That is why the exoskeleton has fixtures. These fixtures ensure correct alignment and help prevent injuries. Now that the exoskeleton is safe to use, it also should be easy to use. That is why we completely redesigned the input device. Dan uses this device to tell the exoskeleton what to do. The device is now holstered on the right leg, always within reach, but never in the way. Dan doesn't need to have something in his hand the whole time, which means he can walk through a room, point at a painting that interests him, or hold the hand of someone he loves, and only pause for a moment to give an input. But we wanted to go even further than that.
The idea was not just to make controlling the exoskeleton easier, but seamless. This is why, after 5 years of meticulous research, we are introducing EEG control, or easier said, mind control, to our exoskeleton. For this, the pilot only has to think about walking, which is measured using electrodes in a cap and then decoded to an action, in this case, walking. Because the goal was never just to build a machine that walks. The goal was to give someone their movement back, as naturally and as completely as possible.
Everything we designed and built this year had one clear purpose: bringing us one step closer to our team goal.
The team goal that we determined almost a year ago.
The team goal that felt so hard to reach at times.
The team goal that would mean giving movement back to Dan.
In the most natural way possible.
Fully self-balanced.
Walking starts with a thought, an intention beginning in the brain, where your neurons send commands to your leg muscles, and the next stride follows. But what can you do when that connection isn't there anymore? When you can still think about walking, but those commands never reach their end destination. This is the reality for people with a spinal cord injury. Their brain still works, their legs still work. It's just a message between them that's been cut off, leaving a gap between mind and body. So how do we fill that gap? What technological bridge can we build to re-establish that connection lost between the brain and movement of the legs? Hi, my name is Jane, the human machine engineer of Project March, and tonight I will explain to you how we've used EEG technology to to enable more natural, truly hands-free control of our exoskeleton. So let me first briefly explain what EEG, electroencephalogram, actually is. All throughout the day, our brains are continuously producing electrical signals. By placing electrodes on one's head, the signals can be measured. And simply, that's EEG, measuring electrical brain activity, all from outside the head. And so what can we do with this electricity? Well, in it, the thoughts of the individual lay hidden. And the challenge here is to uncover them. And this is not an easy task. For our use case, we care about distinguishing two types of thoughts: walking or not. And since these electrical brain signals have to travel through a thick skull, this makes them weak and faint. And thus we need a good tool to do the distinguishing. And therefore, again, we turn to machine learning. By giving a model enough examples of somebody imagining walking, imagining moving their legs, the model learns to recognize that intention, spotting a pattern way too subtle for just a mere person to catch reliably. And this becomes our technological bridge. By measuring brain signals, extracting the user's intention using a machine learning model, and then sending the corresponding commands towards our exoskeleton, we can bypass the spinal cord injury. And this is what we call a brain-computer interface, a way of control of our exoskeleton using EEG technology. And with this technology, we aim to elevate the experience of walking inside an exoskeleton, where it's not just about pressing a button anymore, but a way of control where thought and action become more connected. A small first step towards a future where the exoskeleton might more feel like an actual extension of the user. And of course, EEG technology isn't perfect. The model needs quite a long time to calibrate. It's a long and tedious process, and maybe Dan can confirm that. And also the cap you wear, as you might have all seen, isn't the most stylish. But just by showing the possibility of implementing a brain-computer interface inside an exoskeleton, we can show there are still ways to replace that connection lost between brain and legs, where walking becomes a thought again.
We have now shared our goals for this year and the approach we took to achieve them. But one question still remains. What does it look like in practice? Rather than telling you, we would like to show you. We are thrilled to present a live demonstration of Daan walking in the exoskeleton of Project March 11. But before we begin, we kindly ask you to turn your phone to airplane mode and to turn off Bluetooth. During the demonstration, please hold your applause until I invite you to clap so our pilot and the team can remain fully focused on the demonstration and to avoid any distractions. Please be patient while we complete the final preparations. The first was minimal assistance to put on and take off the exoskeleton. As you will see, Daan will put on the exoskeleton almost entirely by himself. During this process, the coach is the only person allowed to assist. He assists with fastening the left leg at the hip hinge and secures the fixtures that Daan cannot reach. Dan is now securely fastened in the exoskeleton within 5 minutes. The exoskeleton will perform an index search, allowing the hardware to verify the current position of each motor before the demonstration continues. Our second key pillar is hands-free control. The input device communicates with the exoskeleton via Bluetooth. Dan only needs to use the device when he wants to switch to a different motion. Once a motion is selected, he can simply click to start the next movement. Dan will start weight shifting. This is essential for balanced walking and reduce the effort for Dan. This was a successful weight shift. This movement enables our third pillar, self-balanced walking. Dan will now walk in a straight line. He is using the handrails for his own comfort. Can the lights turn on? Please give Dan and the team a big round of applause. Dan will now take off the exoskeleton. The aim was to put the exoskeleton on and take it off within 15 minutes. We managed to take the exoskeleton off in just 1.5 minutes. So the process of putting on and taking off the exoskeleton makes a total of 7 minutes. While we are making preparations for the final part of this demonstration, we would like to briefly introduce what you're about to see next. This feature is still under development and uses Generative Predictive Control, or GPC, which Amy and Mark introduced earlier. It helps the exoskeleton react to its environment in real time, making the decisions for every different situation. We're incredibly proud of what we have successfully implemented this control algorithm. This is the first and only working exoskeleton in the world to demonstrate generative predictive control. Since this approach is still highly experimental, this represents an important contribution to ongoing scientific research and development. Vince Kurtz, the developer of this control algorithm, shared the following about Project March. I've been deeply impressed by the team's hard work and innovation. It's incredibly exciting to see those students pushing the latest cutting-edge research toward applications that really matter. We are not ready yet to demonstrate this controller with Dan inside the exoskeleton, as our priority is to ensure that every step is safe and reliable first. Even though it is still a work in progress, this demonstration shows how far we have come and the progress we have made this year. The movement may look a little rough, but this is because there is no pilot inside the exoskeleton to provide the additional weight and dynamics it normally experiences. The exoskeleton will perform an index search. This is necessary because the system was powered off after Dan stepped out of the exoskeleton. The exoskeleton will start walking self-balanced using generative predictive control. With this, the live demonstration of Project March 11 comes to an end. We're incredibly proud of Dan, of the team, and of everyone who helped make this possible. I would like to thank the demo team standing here tonight. Training lead Tijme, the coach Tom, safety catchers Britt and Boran, the emergency button operator Bart, and the monitor persons Lucia, Wies, and Doris. Please give them all a well-deserved round of applause. You have now seen the technical side of the exoskeleton. Next, we would like to show you a short video of Dan walking through a museum, highlighting its social impact. We will now take a short moment to clear the stage before continuing with the rest of the program.
Je staat er misschien niet bij stil. De wereld is ingericht voor mensen die rechtop staan. Als je in een rolstoel zit, dan klopt je perspectief niet met de rest van de wereld. Je wordt soms anders behandeld, ook al bedoelen mensen dat soms niet zo. Neem van mij aan, zelf staan en zelf lopen is zoveel meer dan alleen mobiel zijn.
What you just saw is a huge milestone for Project March. Dan walking in our exoskeleton with hands-free control. It is a moment we've been working on for the past year. But for us, the real breakthrough is not only in the technology itself. It is in what this technology can make possible for someone with a spinal cord injury. My name is Roos, and I'm the operations manager of Project March 11. And within Project March, the operations department is responsible for bringing our story beyond the technology and sharing it with the outside world. And that story becomes very concrete in a place like a museum. As Linda said at the beginning, walking through a museum is not just about moving from one room to another. It's about stopping when something catches your attention, pointing at an artwork, and standing next to someone at the same height. For many people, this feels completely normal. But for someone with a spinal cord injury, these everyday moments are not always self-evident. And that is why what you just saw matters. Not only because the exoskeleton walked, but because it shows what it could mean in daily life. At Project March, our mission is to improve the quality of life of people with spinal cord injuries by pushing the boundaries of exoskeleton technology. And that mission does not stop at building a prototype. It means showing what is possible, starting conversations, and making this technology more visible and understandable to a broader audience. And that is why raising awareness is such an important part of Project March. To create that awareness, we need to go outside of the Dream Hall. Throughout the year, Project March participates in different kinds of events, and each event starts a different kind of conversation. At healthcare events, we meet people with spinal cord injuries and medical professionals. These conversations help us understand daily life needs, and often give us new ideas for improvement, so that we can keep developing the exoskeleton with the user in mind. At technology events, we exchange knowledge with engineers and companies. There, we receive feedback, discuss technical challenges, and connect with people who can support us with knowledge, materials, or production. This year, for example, we participated at a precision fair, where more than 400 companies came together around high and ultra-precision technology. Education and outreach are also a major part of our year. We give workshops and demonstrations for students, visit technology festivals, and participate in open days. We travel to Limburg to introduce secondary school students with exoskeleton technology. For many young people, this is the first time they see that engineering is not only about machines or code, but also about people and society. And finally, we organize our own major events, such as the design presentation and the reveal you're at today. At our design presentation, more than 500 people came together as we presented this year's newest innovations and revealed the design of our exoskeleton for the first time. All these moments bring together everyone who has followed and supported our journey. And that is exactly where our impact grows, not only through the steps of the exoskeleton, but through everyone who sees the technology, asks a question, or begins to imagine what could be possible. And this was recognized earlier this year, when Project March won both the jury prize as the audience award of the Kiwi Engineering Student Team Award. And winning both prizes was very special for us. It confirmed that people do not only value the technology developed, but also supports the wider purpose behind our work. Project March is also part of a longer journey. Since 2015, every team has built on the work of the teams before them. From next year onwards, future teams will work on the same prototype for 2 years, which gives them more time to test, improve, and refine the technology. And that continuity matters, because real innovation does not happen all at once. It happens step by step, team by team, and year by year. And that is also why Project March is open source, so that others can build upon what we develop. In that way, every lesson learned will contribute to something bigger than Project March alone. And to make all of this possible, we rely on the people and organizations around us. Project March is a non-profit student team, and everything we receive goes directly back into the project. Our team works full-time and voluntarily for 1 year, and we depend on our partners to make both the technical improvement and societal impact possible. Behind every step you saw today, there's a large network of partners that helped us get there. And to show what that collaboration looks like, we would now like to share a short partner video.
Werken met studenten is gewoon heel erg leuk. Het houdt je jong en fris als bedrijf, maar ook als persoon.
Je voelt gewoon de passie en de ambitie die ze hebben en het opzetten van een heel ambitieus project in een jaar.
Kenmerkend voor de studenten is hun enthousiasme, frisse blik en grote inzet.
I really like the energy which I get from young people, young students, who are always very enthusiastic.
Hun gedrevenheid, frisse ideeën en innovatieve aanpak maken de samenwerking inspirerend.
Wij zijn dol op technologie, maar dan vooral op toepasbare technologie. En bij Project Mars komt het echt perfect samen. Dus echt de mens in de technologie.
Project Mars is using an EtherCAT stack in order to control and steer their exoskeleton. And Beckhoff is actually the inventor of EtherCAT. So that was rather simple actually to make that link.
Wij helpen Project Mars met bekend worden bij de media.
We zijn nauw betrokken bij de trainingen waarbij we zelf live aanwezig zijn of dat we op afstand video-opnames beoordelen en daar feedback op geven.
Jullie zijn ook bij ons op kantoor geweest en wat ik daarna ook van mijn collega's terug hoorde is dat jullie met een enorme drive en energie het verhaal aan ons vertellen. En dat werkt heel erg aanstekelijk. Er kwamen heel veel vragen na afloop, dus dan zie je ook echt dat dat helemaal overslaat op iedereen om jullie heen. We zijn heel erg trots dat jullie hiermee de zorg proberen te verbeteren. En we vinden het ook heel gaaf dat jullie de techniek daarmee innoveren.
Voor ons vak is het werken met studenten dat we echt terug moeten naar de kern. En dat heel helder moeten kunnen uitleggen. Dus in het begin is het wel een beetje sturing vanuit onze kant. Maar jullie pakken het heel erg snel op. En dan gaat het gewoon lopen.
Jullie nemen veel risico in zo'n jaar. En jullie stellen jullie zelf hele hoge doelen.
Waarvan je denkt, nou dat gaat nooit niet lukken. Maar uiteindelijk staat er dan toch echt iets waar je helemaal versteld van staat.
Jullie hebben nu als doel om zonder krukken te gaan lopen. Ik vind dat een heel mooi doel en ik ben heel nieuwsgierig hoe dat eruit gaat zien.
Maar gewoon ook het zien dat jullie zo voor elkaar over hebben. Ja, dat is een voorbeeld voor ons ook in het bedrijfsleven.
And I think we as Beckhoff also want to be part of such a nice cause.
Wat is er mooier dan iemand die beperkt is door een dwarslesie weer te kunnen laten lopen en te laten deelnemen aan de maatschappij. Het past heel erg goed bij ons motto, Technology to Transform the Everyday. En dat is precies wat Project Mars doet.
As you could see, Project Mars is not built by the team alone. Our partners support us with the expertise and resources needed to move forward. Their support helps us build the exoskeleton, but also allows us to share our story and show more people what exoskeleton technology can make possible. At the same time, Project Mars depends on everyone who believes in the potential of this technology. That is why we launched a crowdfunding campaign this year. Every contribution, big or small, will help us continue our work. Every step we take starts with people who believe this technology is worth developing. And together, we can take another step towards greater independence for people with spinal cord injuries.
At the beginning of this presentation, Imelda introduced you to our team goal of this year. By July, we wanted to build an exoskeleton that allows our pilot to visit the museum walking self-balanced with hands-free control while interacting naturally with both the exhibits and loved ones and do this with minimal assistance. Today, we're proud to show you the progress that we've made over the past year. This is the result of true teamwork, and I couldn't be prouder of what this team has accomplished. Therefore, I would like to personally thank everyone that has been part of this journey, beginning with the mechanical department with Elke, Amy, Britt, Duncan, Tijmen, Boran en Tom. And to our software department with Mark, Lucia, Carlijn, Jane, Doris, Bies, Daria en Max. to our Embectical department with Rongjin, Bart, Ajin, and Simon. To the operations department with Bente, Okke, and Laila. And to the management department with Imelda, Koen, Roos, and me. And before we wrap up, I would like to switch to Dutch for a moment, because this is something I want to say from the heart. Lieve Daan, kom alsjeblieft het podium op. Je dacht toch niet dat het net zo was als bij de repetitie, hè? 3 jaar lang ben jij onderdeel geweest van Project March. En niet alleen als piloot, maar echt als drijvende kracht binnen het team. Telkens laat jij ons weer zien waar we er eigenlijk echt voor doen. En je hebt zoveel tijd en energie in dit project gestopt. Heel erg bedankt. Wordt echt heel erg gewaardeerd. And finally, I would like to thank everyone for being here today and supporting Project March throughout the entire year. And of course, the evening is not over yet. We would love to invite you to have a drink with us in the foyer. We hope to see you there. This was Project March 11.